Hello, my name is Sam. My presentation and/or video is about the Kepler telescope. It's about all of its discoveries, what the purpose of the telescope is, and what makes up the telescope / what makes it so special. While many other spacecrafts had people working on it and/or controlling it, the Kepler telescope was a totally unmanned spacecraft that was designed to discover Earth-like planets orbiting other stars in our region of the Milky Way. The telescope had many features that helped it with its discovery and its function out in space. It also consisted of a sunshade, photometer, focal plane radiator, high-gain antenna, reaction control tanks, and an SC bus structure that also consisted of photometer electronics. Now, you probably don't know half of the things I had just said. So here are the functions of the most important parts in the Kepler telescope. Now then, even though all the parts do their job, the most important ones in the telescope would be the sunshade, photometer, and focal plane array. With the sunshade, it provides a 55-degree sun avoidance angle for the photometer. It also consists of a 16-degree field view. The sunshade allowed a continuous view of the Cygnus throughout the Kepler telescope's lifetime. Now onto the photometer. It's pretty much a Schmidt telescope. It has a 0.95 aperture and around 12-degree diameter. It collects and records the data the Kepler telescope gathered for however long it stayed up in space. Lastly, the focal plane array. The focal plane array was, at the time, one of the biggest cameras launched into space connected to the Kepler. Long story short, it had a whopping 94.6 megapixels. The array was cooled by a connected heat pipe that also was connected to an external radiator. How the telescope was launched into space was by attaching it and/or putting it atop of a Delta II aircraft. Now then, what inspired the production of this? Well, the German astronomer Johannes Kepler discovered the laws of planetary motion in around 16th to 17th century. How it worked was that the telescope revolved around the sun. It detected planets by observing transits, or tiny dips in brightness, of a star that can occur when a planet crosses in front of the star. 400 years later, NASA proposed a series of unmanned missions in 1990 for these set of goals: to discover new planets, estimate the number of planets in different star systems, and figure out properties of stars that have planetary systems. 10 years later, it was approved. The telescope was launched on March 7, 2009 at 3:46 a.m. It finished 2 missions and lasted for 9.6 years. The telescope was decommissioned on November 18th of 2018. The telescope studied around 150,000 stars and found 2,600 exoplanets that could harbor life, such as Kepler 4b, Kepler 5b, Kepler 6b, and on and on. Every planet that it had discovered started with Kepler and ended with a number. The telescope helped discover that there were more planets than stars in our galaxy. It helped discover different planets on other planets that were diverse from our Earth's planets, and the Kepler telescope observed around 500,000 stars. Kepler 22b was one of the first planets the Kepler telescope had discovered that was the closest to Earth, meaning it could inhabit other life. The Kepler telescope witnessed 61 supernovas. Lastly, with the images and data the Kepler telescope had gotten, it helped scientists make sense of how other planets would look, such as these images. And lastly, here's a short video that summarizes most of what I said, plus a few fun facts.
NASA's Kepler mission has discovered the first near-Earth-sized planet orbiting in the habitable zone of a star very similar to our Sun. Located about 1,400 light-years from Earth in the constellation of Cygnus, the newly discovered planet resides in the Kepler 452 system. The planet, called Kepler 452b, is about 60% larger than Earth. While its mass and composition are not known, researchers believe that it is likely to be a rocky world. The host star of Kepler 452b is the same G-type as our Sun. It is 6 billion years old, 1.5 billion years older than our Sun, and is 10% larger and 20% brighter. Kepler 452b receives only 10% more energy from its star than the Earth does from the Sun. Since the Kepler mission was launched in 2009, it has identified 4,696 planet candidates, 1,000 of which have been confirmed as planets. Of those confirmed, 12 are near Earth size and in the habitable zone of their star. The mission has provided data that has helped to redefine our understanding of stars and planetary systems in our galaxy. Researchers will use this data to continue to make discoveries for years to come.
Overall, the Kepler telescope was remarkably successful with their goal in discovering their planets. Thank you for watching, and I hope you learned some new things about this very fascinating and beneficial telescope that helped shape the view of our galaxy.